EAX has math applied to it. Where's EAX come from? arg4. Okay. Actually, shit. That might actually be a vulnerability. I'm going to mark that for review. That actually comes straight from, that comes straight from an argument to this function. I don't remember what this function is, but we're going to close this so you guys don't look at it anymore.
So that was Aaron Portnoy, and he was presenting in the fall 2009 semester class at NYU Poly. The class was called Reverse Engineering 101, and I believe Dan Guido was the instructor. So Dan introduces him, and he kind of talks about his background, his history, and he starts talking about, assembly and the higher level elements to reverse engineering and vulnerability discovery. And at one point, he's kind of talking through the control flow and sort of how data is being propagated through a function, and he stops and he marks this as a potential vulnerability. And I don't know the context behind it, what the application was, but I remember that so clearly, like this video and watching this. I wasn't a part of the class or anything. I just saw it on Vimeo one day earlier in my career when I started reverse engineering. And this is one of those things that has stuck with me. I think, as a professor or as a lecturer or somebody who teaches others, you never really know what you're going to say is going to stick with them and be this thing that they remember forever, right? And I think everybody's a little different in that, but this was that one element, that one little segment of this, which is the whole talk is great, but it was that one little piece that made me so interested in how this happens, how you can find that. What does that thought process look like? So what I want to do is, I was actually thinking about this recently and decided that what I'll try to do is go through that a little bit. So sort of a message to myself 11 years in the future of what that process kind of feels like. And what we're going to do is we're going to go to, exploit DB. We'll mark by things that have source code or applications available. We'll read some descriptions. We'll go take a look at C source if it's available. And then we'll go ahead and look at a compiled version brought into Ghidra or Binary Ninja. And we'll take a look at what that sort of looks like. What is the pattern or manifestation? What are the different elements that you need to understand in order to find a specific type of bug? That's a hard question to ask in general. It's one that you can answer a little bit better when you narrow down to a specific bug type. So we're talking about vulnerability classes and how software typically fails. And I just kind of want to do a series of videos on what that element, like what that process is like. So if I'm auditing code, whether it's source code or it's something that is being disassembled or decompiled, I want to talk a little bit about what I'm looking for based on the types of ways that I know that software can fail. Let's go ahead and get started. All right, so here we are at exploit DB, and on exploit DB, I'm just going to go ahead and check these two boxes, has app and verified, and we're going to take a look for something that looks interesting to learn about. There is one in particular that I want to talk about today that I've already found and I thought was kind of interesting and I wanted to share. So it does occur in VLC, the VideoLAN VLC media player, and it was kind of an old vulnerability. This is from a while ago. Let's see here, this one. So this one actually shows up as a remote format string, which is kind of interesting to me. You don't really see too many of these. I have seen a couple of them in my career, but I think that this is kind of cool in the sense that the way that you would typically think for a format string to sort of manifest or that you look for is a little bit different here because just like in Aaron Portnoy's video, the input actually comes from a parameter to another function, which is used incorrectly in their own code. So the concept of thinking about how data flows and that sort of data flow analysis is really important to this particular bug. So while I don't think that, understanding format string vulnerabilities is like the number one concern when looking for binary vulnerabilities, I do think that this particular manifestation is really interesting and I wanted to share it. So what we're going to do is inside of exploit DB, exploits 5519 is the actual tag. There's a CVE, so I can jump over to this. I already had these open. And then it tells us that there's a format string vulnerability in HTTPD underscore file callback function inside of the source network HTTPD.c file in VideoLAN VLC 08160 that allows remote attackers to execute arbitrary code via format string specifiers in a connection parameter. What does that mean? right? So we're gonna investigate this and try to see what that actually means. So right here, I can click download the vulnerable app. This will download an executable. What it done is just in a Windows VM that I had, installed it, found the location or the file that contains this, which is I think like libvlc.dll, pulled that out. So we'll be looking at that individually. And then I went to GitHub or SourceForge, found the source code for VLC 086D, downloaded that, and then we'll go ahead and kind of start from there. Right, so it's probably important not to just completely gloss over how you get the source code. In this particular case, this is pretty old. So one of the things we can do is go take a look at archives. So on GitHub, I can go to VLC, look at the tagged releases, and see if it's here. Now, I can't actually find the correct version here. There's versions very close to it and versions where it probably does exist. But what I really want is that 086D. So just doing a quick search for it, we can find it over at SourceForge. So this is 086D. And I can grab one of these packages here, which will have the source inside of it. And that's what we're going to extract and start taking a look to try to find. Remember, when we extract this source code, it does kind of nicely tell us exactly which function and where this actually exists. This is one of the things that when you're looking for test cases and examples to kind of look through, you don't always get this granularity of information. This is actually very specific, which is nice, but we won't always see that. So it kind of gets to become a little bit of a pain. And finding what binary this actually is included in when you install the VLC application from the executable that we acquired from ExploitDB is a little bit of a trial and error process. So you install everything, you look in the install directory, you start throwing stuff into Ghidra, taking a look at the symbols if they exist, trying to find that one function or things around there, starting to look for more format string issues and trying to understand where that actually manifests. So that's what we'll be doing next. I'm going to skip the Windows installation part and the extraction of that DLL file. I think it's something that you would all be able to do pretty easily. And we'll jump right into the C source code for this. All right, so we have the VLC source code open in Sublime Text, and I have opened the file which says that the vulnerability was actually contained in. So this is inside of source network httpd.c inside of the function httpd underscore file callback. And if we take a look, there are actually no format specifier or format string functions in here at all. But we do see indications that there are format string specifiers. So perhaps they're actually added in here. And we do remember taking a look at the vulnerability description here that tells us that it was actually through the connection parameter. So if we take a look at this, the function itself, file callback, does occur at this level, but it actually is really triggered down here. So let's go ahead and take a look at this. Doesn't actually return anything, so I expect that type to be a void. And we can find it this way. So it was actually the third parameter. If I hop back real fast, see if I can do this. There we go. It should be file callback. I want to show that it was the 1, 2, third parameter, right? So let's go to message add and just kind of take a look at what that implementation looks like. And here we have 1, 2, 3, and then a variadic number of parameters after that. If we come down here, we'll see that there is a VSN printf. If I go and look up the prototype for VSN printf, we'll see that there is a char star s, so that's a pointer to the buffer that's going to be receiving this formatted information. And then we have a size tn, which is the number of bytes to actually place into that buffer. So the maximum number of bytes and -1. And then we have this format string. This should be a constant char star, so this should be a constant immutable string. But unfortunately, in one of the elements where this is used, it isn't actually that case. So let's go ahead and take a look at how that manifests here. So as long as, and this will take the 1, 2, 3, so PSZ value is the thing that we're kind of sensitive to. This is the problem that if we actually control this, there's going to be an issue here, okay? So the way that they end up doing this is sort of a wrapper function around VSN printf is to call HTTPD message add. So if they mess up these parameters here, then there could be an issue. Now this is a variadic function, which means that we don't have to put any arguments after this, or we can put other argument, like many arguments past this. What's really interesting here is the number of ways that this is called. So if I look at HBD message add here, the third parameter is %d, which is a format specifier, and then you have the I_CSEQ. This is exactly what I would expect to see. I imagine this is some type of integer that's going to be smashed into this. Okay, no problem. So we continue on, and then there's a hard-coded string or just a static string VLC server with nothing to format. No problem at all. It handles both of those cases. But let's continue to look down this list and look at the third parameter, another %d, some basic realm, whatever else with some other stuff behind it, a %d, a %s, a %s, a %s, and then PSE connection. So PSE connection, if we take a look at this a little bit more, actually comes from a get message. So there's a query to the server for an element called connection, and that value gets placed here. As long as that's not null, it's going to be put into this message add as the actual format specifier. Now this should just be a normal string. So whatever the details are this normally. But if we were to make a request with the connection value as being %s or %x, it's going to interpret that as a legitimate format specifier and start popping data off of the stack. Let's take a look at what this looks like. Now, here I have a sample example. I didn't want to make that sound, and it did. So we have this function called main, where we have a input stack buffer with 32 bytes. We're going to fgets from standard in 32 bytes into that, and then we're going to print this out normally. So this is exactly how we would expect a normal format string function to look like. In this case, printf with a %s, and then some input that is going to be formatted by that format specifier %s. So I can put hello, my name is, and then that %s, and whatever string exists in that input buffer is going to be concatenated or smashed together, and it's going to print out hello, my name is John, or whatever we enter. The problem exists where we actually confuse what that format string specifier format parameter is, and actually make it user controlled, because what will happen is at execution time, that printf function is going to assume that the data on the stack at that point is what the format specifier is. So it's going to interpret that as like a %s, and if it does, it'll pop the next data, the next bit of data off of the stack and continue down. The issue is when you combine this with a %n, which prints the number of bytes printed up to that point, you can actually get obtain something called a write what where primitive that allows you to write whatever you want sort of wherever you want, which is a really bad thing, right? So if we try to compile this, I'll try not to make that donk sound again, it's going to warn us and tell us like, yo, this seems to be a problem. Most compilers these days are going to warn you and tell you that this is an issue. Even if I created a wrapper function to try to pass things through it, it's still going to say, this looks a little weird, this is a little strange. But I imagine there are certain types of cases in complex code where it might just give up and say, I'm not going to analyze that far. Maybe that's not the case. But the bottom line is, I think the reason why we don't see these types of bugs too often anymore is because of this. And most people nowadays, if there are warnings, we're going to try to address those, right? I know many cases where that isn't the case. Okay, so let's run this and see what happens. Hey out, it's going to ask for some input, so I'll put John. Okay, so it prints John, right? So the input, the first line is where I typed in, the second line is this guy, and the third line is this guy. But what if I run this again and put in %x? What is that? So the weird thing is that this one, %x, was actually formatted by this. This guy was actually interpreted as a %s, right, or %x, which formats the next slot on the stack as hexadecimal, right? So this is a problem in that this is data off of the stack. And I can continue to do this over and over. It should just be easier to do it this way and over again, and we'll continue to pop things off, right? One of the issues that we'll end up seeing with this is if I couple this, and I don't know if I can get it to crash, but we can try. It's %n, %n. There you go. Segmentation fault, core dump. Is the issue that we started popping things off the stack, and then we said %n, and it goes, wherever that next parameter is where I'm going to write the number of bytes that have been written to at that location. So it tried to, this is probably a write access violation, and then essentially tried to write to some random crap on the stack and ended up seg faulting. right? So this is the pattern that we're looking for. This is actually kind of what we want to look for and try to avoid. So the issue here is that when HTTPD message add is called with a third parameter, which is PSC value, which leads to essentially this format specifier, this format parameter in this format string function, that we're going to have a problem. And that does actually happen in this case. If we take a look or grep through all HTTPD message add uses in this code base, we'll see that it's used many locations and only one of them is where this happens. And sure enough, this particular value ends up being user controlled at that point. If it wasn't user controlled at that point, like, doesn't really matter, right? So the problem is that ends up being something that a user can do. So let's go ahead and throw this into Ghidra, and we'll take a look at what that looks like. Afterwards, we'll quickly throw it into Binary Ninja and take a look there too. All right, so here we are inside of Ghidra. I have our libvlc.dll in here, and this is the version that we were just taking a look at the source code for. So the issue, right, that we're looking for is anytime we see a format string function, in this case, it's been named _VSN printf. It is the VSN printf function that we're considering and have been talking about in this video. When we take a look at this third parameter here, this param3, right, we want to take a look at any location where this is called. So what I can do is double click on this. We can take a look at the xrefs, and there's actually only one. Actually, here's going to be 4. So let's go here, 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 and here. So every single location where this ends up being used, what we're really interested in is what that third parameter actually is. And it turns like all of these cases, there are sort of wrapper functions around this. So we want to be sensitive to VSN printf's third parameter. And it turns out that that comes directly from this input here. Okay, so what's really interesting is if I take a look at all of these cross references and start looking at where this is called and what parameters are being passed into it, you can see here that this isn't actually marked as a function, it's an undefined function. So I'll continue down. Ghidra didn't do good analysis on this to tell me what parameters are in, so we can ignore that for right now and continue on. I see here that the third one ends up being this, and this is probably what a lot of these are going to look like. I can essentially go here and hit string. So that's a %s. Okay, the third parameter in this particular case is good and safe. If I go here, this one ends up being another one. So we got to go over here. I can hit Y to repeat that last thing. And that's a %D. So that looks good. And we'll continue this process down until we hit something that looks strange. So that's a %D. That's okay. Here is ivar7. If I look at ivar7, ivar7 comes from connection, string compare. So this is the guy, right? So this is not being marked as a function. I can go ahead and hit F to mark it as a function. I mean, I actually did a good job in getting the parameters for it, so that's nice. This is a little wonky in the sense that we don't actually know what's going in here. So we have a little bit of work to try to understand where this data flow actually comes from. If we take a look on this layer, obviously we know through the calling convention for Windows 64-bit, we're trying to, actually it's a 32-bit application, so Windows 32-bit application, which order that the parameters are being passed to the stack, and how all of this is going to be passed over. So we want to be sensitive into what's being loaded into registers and pushed onto the stack. And notice that this particular value is the one that's actually being user controlled or can be user controlled, right? So we'll notice that this function is not actually listed as the HTTP file callback, but it is. So that is unfortunately a case where we don't actually have that symbol here, so we couldn't trigger on that in the first place. But the bottom line is the actual manifestation, or that thing that we're looking for, those characteristics, is that we have something that drills into and utilizes a format string function, and we have to trace up to where that data comes from, go look at those cross references and analyze manually every single one of them. In this particular case, there's an issue. We have to either fix analysis or just skip that altogether. We start walking down each one and determining, is that third parameter safe? And we will eventually find one, like in this case, where it is not safe. The data that gets sent to that parameter, the format parameter is not safe and it is user controlled. So this is the sort of red flag, or the thing that would make you stop, just like our Portnoy did, and say that might be an issue and actually mark it. Because we don't actually know specifically where this IVAR7 comes from, because everything looks a little wonky right here, we have to do a little bit of work to try to figure out how data flow comes into this and whether or not that's user controlled, what actually hits this function. There's a sort of a problem in that this was an undefined function, so we may not know what actually calls or references it. Once we set it as defined, we can go ahead and take a look at cross references and try to understand where things are coming from and trace its way back into how you get data back, how you get data into the application. Okay, let's take a look at what this looks like in Binary Ninja. So I already have this open. I'm having to search for the function. Let's see if we can find that real fast. Message add. I'll go ahead and do this. This is high level IL. Yeah, high level IL. So here's our same thing. We have 1, 2, 3, this third argument. So we can click this and start looking down all of the cases where this is called. What's nice is we'll get sort of like a preview of what's here. That wasn't listed as a string, so we can go over there and just press A. That'll make it a string, right? So now, instead of having to double click on everything and then refine it, for the most part, we can just see the hints on what those are. So we'll start walking our way down to each one of these and taking a look at whether or not we think the parameters, the third one specifically, is user controlled or not. It's %s. There's a content length with some other value, location, content length, and connection with this value. Again, not cleanly understanding exactly where this comes from. If we look at the source code for this guy, message added actually comes from HTTP message get. So the HTTP message get is what's not actually being resolved nicely here. So having to understand and go back and figure out what this means in this context is important to figuring out whether or not this value is user controllable. If there's something that we can taint there, that would be the problem. And that is the issue here in this case. When I'm looking for format string functions or format string vulnerabilities, typically my use case for this is to look at all of the inputs or imports and try to identify anything that is a format string function. Go reference their prototypes, because I always forget which placement is the format string specifier. Go ahead and find that. And then for each one of those functions, start looking at all the cross references to them and then trying to understand what's being passed to it. Okay. Sometimes you might have to look many levels. So you might have a case where your format string function is being called. The parameter passed to it for format is actually passed from a variable in that function. And that comes from an argument from another function, which comes from an argument from another function, and you have things passed down this long call chain, which is a real pain to analyze and try to trace your way back to, but it's worth the time to do it. So I hope that was interesting for you. This is one of the ways that when you're looking for bugs, the types of process that you go through, and it really takes knowledge of a lot of different bug types and manifestations. This is only one, right? And that's not even like all of the ways that you would look for format string vulnerabilities or bugs, but it's one of them. In the future, we can take a look at other types of bug types, things like integer overflows, use after free, double freeze, things like that you can take a look for, and try to start building up that knowledge set of what to look for when you're analyzing code for bugs.